When clusters have irregular shapes, k-means can struggle to separate them correctly. That's where DBSCAN comes in, a density-based clustering algorithm that groups points packed closely together. So how does it actually work? DBSCAN builds its clusters around density. It looks for regions where the points sit close together. It starts by picking a point and checking how many neighbors are within a small distance. Counting the point itself, that's 5, which is more than the minimum of 4 we chose. So it becomes a core point and starts a new cluster. The algorithm then moves to each neighboring point and performs the same check again. As more core points are found, the cluster keeps growing until no more connected core points remain. The algorithm repeats this process until every point has been visited, so a second cluster forms. Now, points that fall inside a core point circle, but don't reach the minimum on their own, become border points. Points outside every circle, too far from any core point, are labeled as noise or outliers. But what determines whether a point becomes a core point? There are 2 key parameters to evaluate density. First, epsilon, which defines the neighborhood radius. And second, MinPts, the minimum number of points inside that radius, including the point itself. Increasing epsilon makes the circle larger, while increasing MinPts requires denser regions before a cluster can form. Choosing these values well is important, because they decide what DBSCAN considers a cluster. So why reach for DBSCAN? It has 3 big advantages over k-means. First, you don't have to choose the number of clusters beforehand. Second, it can discover irregularly shaped clusters. And third, it naturally identifies outliers as noise. However, DBSCAN is sensitive to its parameters, and it can struggle when different clusters have very different densities.